Everyone, it's Mr. Ekstrom going over our fun new sum and difference rules. And what's going on in this exercise? We are going to look at values like negative 15 degrees that are not on the unit circle. And over on the right here, I'm just going to remind ourselves, what are the values in the unit circle in degrees? So if it's not one of these 5 numbers, then we need to figure out a way to combine them, either with addition or subtraction. So, and we are not going to use a calculator. You can, of course, plug in sine negative 15 degrees on your calculator and you'll get a decimal. All these answers are going to be irrational. That is, they'll have a square root of 2, a square root of 3, maybe multiply those two together, you get a square root of 6. So we're looking for, as it says here, an exact value. That means no calculator. So here's the first little game. What do we do to get negative 15? Well, we look over here and I see 45 and 30. So this is in fact equivalent to the sine of, see if my pen will work here. Let's see, we'll put the 30 first to get a negative value. And now our new rule comes into effect. Sine combines, so I am going to write sine cosine. It's subtraction, so I'm going to use the minus sign there. And you don't have to do it this way, but I kind of like to. Also, you don't really need to memorize them if you've got those rules right by your side there. But what is this? This is the alpha. This is the beta. This is the alpha. I'm sorry, then you switch them. This is the beta. This is the alpha. And then we know these values, so I'll just plug in those 4 values. So I paused the video and plugged those in, and you can see we have 2 different coefficients in front of this same value, root 2 over 2. So you can combine those and you'll get, well, actually let's do the multiplication. So you'll have a 4 down in the denominator, and then we have root 2 minus root 2 times root 3, which is root 6. Let's take a look at one that uses the tangent rule because we've got some tricky fraction work to do there. But there's the answer to number 1. So let's take a look at number 5, and we are looking at 105 degrees. I've rewritten our unit circle values over here, and there are a few different ways to do this. To get 105 degrees, I actually thought of taking 135 and what did I do? 135 minus 30. But let's stick with quadrant 1. And here we have 60 plus 45. And then we can use our tangent rule of addition. So this is the same thing as the tangent of these 2 added up. And what's our rule of tangent addition? Well, it gives us a pretty big fraction here. We're going to have the tangent of alpha plus the tangent of beta on the top, and then 1 minus the product of those 2 tangent values. Then I'll plug in my alpha and my beta, which are 60 and 45. And 60 and 45. And now we can evaluate. Tangent of 45, of course, is easy. That's 1. And then what is the tangent of 60 degrees? So we take our trig values, and yes, of course, tangent of 60 is root 3 over 2 over 1 over 2, or just root 3 over 1, or just root 3. So you plug these in. The ones, you don't have to do this, but I think this looks a little prettier if we just use commutative property and switch that around. Now this is an answer, but it is not an acceptable answer, right? We have a radical down in the denominator here. So how do we get rid of a binomial with a radical? We multiply it by its conjugate. So what is its conjugate here? 1 plus root 3, and that'll get rid of the radical in the denominator. Of course, we will have a radical in the numerator, but that's okay. So what does this equal? We get difference of squares here, so 1 squared, and it is a difference of squares, minus root 3 squared. That'll just simplify to negative 2. I might even just go ahead and do that here. Negative 2. And then what is this? We're going to get a square. Of course, a squared plus 2ab plus b squared. So there's a squared in the front there. It's a little messy. 2ab. So there's 2 of these guys. And then root 3 squared again. That simplifies to 4, right? 1 plus 3. 4 plus 2 root 3. We like our radicals on the end there. And then this simplifies. Divide both of the terms up above by negative 2, and you get a negative 2 minus root 3. And there is our simplified answer. And it is an exact value, one that the calculator would not give you. Finally, let's take a look at number 15, which looks like a big old mess. We have inverses of trig functions inside parentheses of a trig function. But that's all right, and actually sine of inverse sine is going to simplify very nicely. But we need to talk about what to do with this term. How are we going to find the sine of that? But first, let's just check that we do have a minus sign here, so this is our rule of differences, and it's sine, so we combine. We get the sine of alpha times the cosine of beta. It's subtraction, so we keep the minus sign. And then we're going to plug in our betas, our alpha and our beta. And this is where okay, sorry, I had to rewrite that because I hadn't left myself enough room. But our alpha here is this kind of annoying inverse cosine. We need a value for that. But let's write in everything else. So our beta here is 2x, so that's easy enough. And then this will be the sine of beta. Sorry, I got ahead of myself there. The beta is actually what we see here. This is beta. So I got to plug that value in. Then we'll plug this value in. This is what I was thinking was easy enough. The sine of the inverse sine is going to just cancel out. And then finally we get this also. Cosine of okay, so 3 of these simplifications will be quite easy, and I'll put them in blue, I guess. We're going to save this one. I'm sorry, we're going to save this one. I am making a lot of mistakes in this video, but this one is, the first one is fairly simple. We're going to save the second one. So what angle would give us, the cosine would give us root 2 over 2? Well, this is just pi over 4. Right? So this is sine of pi over 4, which we actually know. And then this is going to be multiplied times our mystery value. Subtract, here's where these guys just cancel each other out, and this becomes 2x. And then these also cosine of the inverse cosine. And maybe I should just go back and quickly solve sine of pi over 4. I can get an eraser here. Sine of pi over 4 is the same as cosine pi over 4. Oh, look at that. I erased my... Okay, that's better. So those three values should be fairly straightforward. But what do we do with this guy here? Well, we're going to draw a right triangle and ask ourselves what angle, we'll call it theta, of course, what angle would give us a sine of 2x? We know that the sine of this angle equals 2x. And I'm going to put a 1 underneath it so it looks like a ratio. It is a ratio. Well, we know that's opposite over hypotenuse. And now, what would be this third side? Because that's what we need for cosine. And we can just use the Pythagorean theorem. I'll pause and write that out. And here's our right triangle, and here's solving for y. One thing to be careful about is this guy right here. When you square that side and it has a coefficient, remember that 2x squared is not 2x squared. It's 2 squared times x squared. So we get this 4x down here. Oh, and I've left out the square. There we go. Good thing we double check that. That is our y value of this other side here. And what's the cosine of theta? That is, what is the cosine of the angle up here that gives you a sine equal to 2x? Well, it is y. You could say it's adjacent over hypotenuse, but that would just be y over 1. So we have the cosine value here as square root. Maybe I will color code that. Where did that come from? That came from down here. The square root of 1 minus 4x squared. And now we need to simplify this guy. Really, most of the simplifying, I guess you would just call rearranging. This is all over 2. We have a divide by 2 in the first term and the second term, so we can combine that into one denominator. And then what do we have in the first term up above? Well, if you take this root 2 and put it in there, you get one radical of root 2 times 1. Root 2 times root 1, yeah. And then this just distributes, so you get 8x squared. So that's your first term. It's minus, and then what do we have on the other side? It's 2x times root 2, and we are done. Oh, geez, don't do what I did. We are almost done. But in your rush to be done, don't write down 3 instead of 2. Hope that helped.